If your fusion reactor looks like it's eating itself, congratulations! You've just met the Fusiodyne. Think the sun, but with a bad attitude. Let's unravel the mystery. Deep in the vaults of experimental science, the Fusiodyne reactor lurks. An anti-fusion beast, born from curiosity and just a hint of madness. Unlike traditional fusion, where atoms merge and unleash blinding energy, Fusiodyne reactors twist the script. They trap that energy, dragging it down a cosmic drain. Picture fusion as a party. Fusiodyne is the bouncer who locks the doors and shuts off the lights. Temperatures plummet, reactions slow, and what's left isn't a burst of power, but a chilling void. Why build such a thing? To probe the limits of physics and maybe, just maybe, find new rules in the darkness. Welcome to the shadow side of the sun. Science doesn't get much stranger than this. Now, let's journey deeper into the veins and arteries of the dark Fusiodyne experiment. Every reactor lives and dies by its fuel. And here, the choice is anything but ordinary. Instead of the usual deuterium or tritium, the Fusiodyne feeds on a cocktail of exotic isotopes, unstable, rare, and fiercely reactive. Show slow-motion shots of glowing, swirling plasma and vials labeled with isotope names. Each isotope is stored in ultra-sealed cryogenic chambers, moved only by robotic arms. No human ever touches this fuel. Show robotic manipulators moving fuel canisters in a secure lab. Their volatility demands respect. Even the smallest leak could trigger a cascade of runaway reactions, or worse, a chilling shutdown that freezes the entire core. Cut to close-ups of warning lights and containment fields. But fuel is only half the story. To keep this anti-fusion beast from devouring itself, a coolant system unlike any other was engineered. Show 3D animation of intricate coolant pipes weaving through the reactor. Liquid helium, colder than deep space, courses through super-insulated conduits, absorbing the reactor's icy output and stabilizing temperatures to fractions of a degree. But what truly sets the dark Fusiodyne apart is its staggering energy output. Unlike traditional fusion reactors, which struggle to break even, the Fusiodyne's anti-fusion reactions unleash bursts of energy reaching up to 1.5 gigawatts, enough to power a small city. Show animated energy graphs and glowing readouts. This output is achieved through a unique mechanism. When the exotic isotopes collide, they don't simply fuse. They undergo a controlled annihilation, releasing energy not just as heat, but as high-frequency electromagnetic pulses. These pulses are captured by specialized induction coils lining the core, converting raw reaction energy directly into usable electricity with unprecedented efficiency. Safety is everything. Show flashing red safety overlays, automated shutoff valves, and emergency coolant reservoirs. Multiple redundant systems monitor pressure, temperature, and flow, ready to flood the core with backup coolant at the first sign of trouble. Show control room displays and automated safety mechanisms activating. In the Fusiodyne, fuel is the spark, coolant the shield, and energy the roaring heart, locked in a delicate dance on the razor's edge of physics. Slow zoom out from the reactor, bathed in blue light. Here, science doesn't just push boundaries, it rewrites them, drop by frozen drop and watt by electrifying watt. It begins with a single, shrill alarm, cutting through the hum of machines like a knife. Sound, sudden alarm blaring, red warning lights flashing across control panels. In the blink of an eye, the dark Fusiodyne's delicate balance shatters. A hairline fracture in a coolant conduit, barely visible but fatal, triggers a cascade of chaos. Show thermal camera footage of coolant temperatures spiking, animated pressure gauges slamming into the red. Automated systems spring to life, flooding the core with emergency coolant. But the exotic isotopes are already surging beyond control. Cut to frantic robotic arms scrambling to seal fuel chambers. Steam and vapor erupt from fissures in containment units. The air vibrates with klaxons and computer-generated voices, each one counting down to critical failure. Overlay digital countdown timer, rapid cuts between panicked control room operators and reactor core footage. Inside the core, plasma arcs whip and snarl, unstable energy clawing at its restraints. Visual 3D animation of the core destabilizing, energy surges cracking containment fields. Temperatures spike, containment fields flicker, and the coolant, once so cold, boils away in an instant. Show coolant reservoirs emptying, animated blue coolant turning to vapor. A final, deafening roar, then silence. The reactor plunges into darkness, emergency lights casting eerie shadows over ruined machinery. Slow motion debris settling, vapor clouds rolling through shattered corridors. In the aftermath, robotic teams sweep through the devastation, mapping radiation and sealing breaches. Drone footage, scorched reactor hull, robotic arms welding emergency seals. The price of pushing the limits, a stark reminder that even the boldest science can falter. Fade to black, with the echo of alarms fading into silence. In the dark Fusiodyne, triumph and catastrophe are separated by the thinnest line, a line crossed in a single, fateful moment.